Boys, today we're looking at loan repayments. So in the past we've looked at what's called a reducing balance loan, and that was the previous topic. And what's interesting to note about a reducing balance loan is that it is an annuity because we are making regular payments to pay off the loan. That makes it a scenario like an annuity, and so we can actually use the table of present value interest factors to help solve problems involving reducing balance loans. So when we were doing present value of annuity last time, we had this formula and something like this. The present value of an annuity is equal to the monthly contribution A times by the present value interest factor. Now, when we think about loans, we use the same formula, except the parts of the formula stand for different things. So the PVA stands for the loan amount. The A stands for the repayment, like the monthly repayment. So the repayment, and then the present value interest factor is the same. So we'll look at a couple of examples where we use this formula here to solve problems involving loans. Jump to question 7 on page 20. This gives us a question with everything all sitting together with the table that we can do first, and then we'll look at another example where we'll need to duck into our textbook to find the values we need from the present value interest factor table. Okay, so question 7, it says the table shows the present value interest factors for some monthly interest rates and loan terms in months. Mark borrows $10,000 for a car. He arranges to repay the loan with monthly repayments over 4 years. So a reducing balance loan. He's charged 7.2% per annum interest. Using the table, calculate the amount of interest Mark will pay over the term of the loan. So we've got to find the amount of interest. Before we find the amount of interest, we're going to need what he repays in total for the loan. To get to that, we're going to need how much he pays each month. So we can find out his monthly repayments using that table we had before, that formula we had before. This time we've been given the amount for the loan, and so we need to find, so that our formula was the loan amount equals the repayment times by the value from the table, and so we want just the repayment amount, so we just need to divide. That's going to be equal to dividing 10,000 by the value from the table we need. So 10,000 divided by the value from the table. Now, what is that value? Well, it's 7.2% per annum, which if we divide by 12 gives us 0.6%. So it's going to be this first one here. And it's for 4 years every month, so that's 48. So there's our value, 41.59882. So we'll stick that in. Okay, and that gives us an answer of 240.39. And 14, and so that's going to be a monthly repayment amount of 240.39. Okay, so now we've got that, we can calculate the total amount paid and then find the interest. So the total paid is going to be $240.39 times that by how many times we did it, 48. So a grand total of 11,538.72. And so from there we can see that the interest is going to be that minus 10,000. So the interest will be equal to the difference, which is 1538.72 minus 10,000, which equals 1,000. So I just missed 8 there. So it'll be 1,538.72. Okay, let's look at another example. Okay, so here's a question that came from the HSC in 2008, but it's just been modified to deal with the changes in the course. Because of that, we'll need to use the table from the textbook, which you'll also need to refer to as you're doing exercises from 7D. You need to look back at the table at the start of 7C, the present value interest table. Okay, so let's have a look at this one. Well, Julie, she takes out a loan of $290,000. The terms of the loan are 8.4% per annum over 25 years with monthly repayments. Show that the minimum monthly repayment is $2,315.65 to the nearest cent. All right, so we need to find the repayment. And so once again, we're going to divide the loan amount by the present value interest factor. So the repayment is going to be equal to the loan amount, $290,000, divided by the value from the table. Now, we're going to need our textbook page. So if you go to the textbook, it will look something like this. And you can see there for this example, because we've got 8.4% per annum, that becomes 0.7%. And the term of the loan is 25 years, so it's going to be 300 payments. So the relevant value in the table for us is going to be 125.2349 down here. Okay, so going back to our question, let's sub that in. 125.2349. Okay, so that's equal to 2315.65. Well, it comes out as 648, blah, 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 which is what we require. 2315.65. Okay, as required, so that's part 1 done. Part A. Part B, determine the total amount paid for the loan. Now, it's actually not a 30-year loan, it's 25 years. So over 25 years, how much is paid? So the total is going to be equal to 25 times by that amount. which gives us a total of 694, 695. Okay, part C. Each month, Julie decides to pay $250 more than the minimum monthly repayment. So she has to pay the minimum amount over here, but she's paying $250 more. The question is, would she be able to repay the loan in 20 years? So rather than 25-year loan, could she repay it in 20 years? So to figure that out, firstly we need to work out how much she would need to pay per month to pay it off in 20 years. So using our present value interest factors table, and then after that we can compare that to the amount she's deciding to pay and see which one is bigger. Okay, so to pay it off in 20 years, what's the monthly repayment she's going to have to do? She's going to need repayments equal to the following: 290,000 divided by the present value interest factor. So to get that now, I've got to go back to the table, and instead of going for 300 periods, which would be for 25 years, we go to 240, which would be for 20 years. And the rate's still the same, so the value we get is 116.0760. So let's put that in, 116.0760, and there's 1 there, so 116, and so the value is 2498.36 per month. So if that's what is required to pay it off in 20 years, does her addition of 250 give her enough? So Julie pays, how much does she pay per month? She pays that first amount, 23, like from earlier in the question, 2315.65. We're going to add 250 to that, and that's equal to 2565 0.65, which is greater than 2498.36. Therefore, she will pay it off. Excellent. Good luck with your questions on loan repayments.